Hello everyone. So in the last class, we had spoken about the cyclic chains with the double bond, triple bond, bicyclo. We had spoken about the naming of alkane, alkenes, and alkynes. So this is all what we have covered till date. Now we'll be talking about the functional group naming. By the way, now we have already learned most of the rules which are required to name a particular compound, except the only ones where the functional groups are involved. And now today we will understand what exactly are the functional groups and how do we name these compounds. So what are functional groups? We know that the basic carbon chains or basic organic compound, basic means the most easiest carbon compounds are nothing else but made up of carbon and hydrogen. Now if we add some other element apart from carbon and hydrogen, or the compounds which are made up of other elements, or you can say the groups which are made up of other elements, we introduce them to the carbon chain of our simple hydrocarbon chain, then these are called as functional groups. Or you can say these are the groups which are responsible for a particular behavior of a compound. For example, if I say I have, let's say, CH3, CH2, OH. So this compound, see, if you talk about this compound has a new entity over here that is OH, right? Earlier, if I wouldn't have this OH, if it would be CH3, CH3, it would have been simple ethane. But now, by the introduction of this OH in this group, this compound has got completely changed. It is an alcohol and will possess some specific kind of properties which ethane cannot. For example, this alcohol now, the OH group which is present over here is alcohol. The name will be different for it. The physical and chemical properties will be entirely different and will be based on this group now rather than just being based on the carbons. So this will be water soluble because it can form hydrogen bonds with the water, which was not possible in the case of ethane. So all the properties gets changed due to the addition or due to the introduction of the functional group. It will have higher melting point or higher boiling point, not higher melting point but higher boiling point. Alcohols are basically liquid, and then you go ahead and then the higher alcohols or the bigger chain alcohols become solid. So when we talk about ethanol is liquid and it has a higher boiling point as compared to ethane. So there are similar such properties which will vary or which will get added new due to the presence of the functional groups. So now what exactly are the functional groups? The groups which are responsible for the properties of a compound are known as functional groups. As soon as the introduction of these groups will happen in the carbon chain, carbon themselves will become little insignificant in terms of properties, and these groups will play a major role in the properties of the compound. Okay, so what are different groups we will be encountering in grade 11th? We will be talking about the first group, that is alcohol. Alcohol is OH group. I have shown a dash over here to represent that it is connected to the carbon chain using this one bond, and this group is called as alcohol. Similarly, instead of OH, if the group becomes SH, this becomes thioalcohol. Next is O, simple O, that is oxygen. And this oxygen, you can see here I have left the two dashes which represent that it is connected to one carbon chain over here and another carbon chain on the other end. So it's like basically oxygen has two hands. From this hand also it is connected to the carbon chain, and from this hand also it is connected to the carbon chain. Now this functional group is called as ether. Similarly, instead of O, if I take S, the thing will be called as thioether. If you notice here, in case of alcohol also it was a similar change, that from OH, if you make it SH, it becomes thioalcohol. So changing of oxygen to sulfur, or basically wherever the oxygen is, if you make it to S, that is using sulfur at that place, we add a new term over there that is called as thio. Thio means nothing else but sulfur. It represents that instead of oxygen we have sulfur in the functional group. So this is called as thioether. Next group is SO3H. It is called as sulfonic acid. We will be talking about these groups in detail, their names, their appearance, and their priority order with respect to each other. Okay. Next is sulfonate ester. What is sulfonate ester? If you can see, at from one bond, sulfur is connected to the carbon chain, and from the other end, oxygen is connected to the carbon chain. So you will have two carbon chains. From one side, it will be connected to sulfur. From another end, it will be connected to the oxygen, and you have two oxygens over here as double bonded. So this is called as sulfonate ester. Okay. Similarly, we have carboxylic acid, COOH group. Then we have next group, that is COOCO. Here again, this group is a group which fits in between the carbon chains. One carbon chain will be at this end and another carbon chain will be at this end, and this is called as acid anhydride. Next is acid halide. Acid halide is C double bond OX. Now here if you see, in carboxylic acid also you have C double bond O. In acid anhydrides also you have C double bond O. Acid halide also you have C double bond O. There is a change in the next attachment, but C double bond O is still remain common. This is, and everywhere we are using this term, carboxylic acid, acid anhydride, acid halide. So basically, these are the groups which are of similar kind, not exactly similar kind. I must not say similar kind. All these belongs to a certain family, and that family is called as acid derivatives. Not only these, there are furthermore, let's see them also, and then I'll categorize them into one category, that is acid derivatives. So let's see what are the rest of the functional groups. Next is CONH2. Again, CO is same as another acids, and the only difference is in the next group, that is NH2. So every time CO is remaining same and the other bond with carbon is changing, right? Next is ester. We had seen sulfonic ester where we had S double bond O, single bond O, and a bond. So here it was connecting to one chain, and here also it was connecting to the another chain. Similar way, we have a normal ester. Normal ester is C double bond O, single bond O. Carbon is connected to one chain at one end, and oxygen is connected to the another chain on the other end. So this is called ester. All these groups still here, starting from basically here, 8th, 9th, 10th and 11th. These all groups are similar in appearance with respect to carboxylic acid. So carboxylic acid is COOH. So we are keeping this thing constant and changing this another bond with a carbon and putting different things over there, and hence the name is changing. So all these four compounds, which are 9th, 10th cut sorry which are 8th, 9th, 10th and 11th, basically acid anhydrides, acid halides, acid amides and ester. All these groups are called as carboxylic acid derivatives. What does it mean? It means that these are the groups which have been designed or derived from the carboxylic acid, which have some of the similarity with the carboxylic acid, and these can be formed by doing some reactions in the carboxylic acid compounds. Okay. Next functional group what we have is cyanide, C triple bond N. This group is also called as nitrile. N triple bond C. This is called as isocyanate. We have spoken about these groups before. This is called as isocyanide or isonitrile group. COH, C double bond OH. This is also called as CHO. This is aldehyde. C double bond O, simple C double bond O, where it is connected to the carbon chain from two ends. This is called as ketone. Next is amine, primary amine. We have also spoken about amine. We also call it as amine. Whatever you want to call it, you can call it. And we had discussed at that time that if nitrogen is connected to only one carbon chain, then it is called as primary amine. If it is connected to two carbon chains, it is called as secondary amine. If it is connected to three carbon chains, it is called as tertiary amine. So all this we have already discussed earlier. Now we have this group C double bond NOH. This is called as oxime group. Next is N double bond N. This is azo group. N triple bond N. This is called as diazonium group. N double bond oxygen and one coordinate bond with oxygen. One is pi bond and another is the coordinate bond, and it forms nitro. So see here, nitro is connected to the carbon chain using nitrogen. It has two bonds, one as a coordinate bond with oxygen, another is pi bond with oxygen. And this group is also written as NO2 and we write it as nitro. Okay. Next, we have another functional group as X. X is nothing else but halogens. Halogens can be fluorine, chlorine, bromine, iodine. So we can name them as chloro, bromo, fluoro, iodo. Depending upon you're talking about chloro, you're talking about bromo, you're talking about iodo, or you're talking about fluoro. Okay. So let's see next, last few functional groups. Next is nitroso. N double bond O is nitroso. And if you remember, this last one is a nitrito group. We have just now spoken about nitro. What was the nitro group? Nitro group was this, or you can also write it as N, one coordinate bond and double bond O. And this nitrogen is connected to the carbon chain. This kind of structure, when NO2 possess, then it is called as nitro. Whereas if the structure is again where you have two oxygens and one nitrogen, but rather than following this structure, it follows this structure where your oxygen is connected to the carbon chain and you have nitrogen forming a normal sigma bond with one oxygen and the pi bond with another oxygen, and the point of attachment with the carbon chain is oxygen, not nitrogen. See the difference over here. Here nitrogen is acting as a connecting point, whereas here oxygen is acting as a connecting point. There is no coordinate bond over here. Then this group is called as nitrito group. If you write it in short, it will again will be written as this, or to be very honest, it will be written as not like this. It will be ONO. That's how we'll be writing it. But many a times you will find people writing it in very short as NO2. So this group is called as nitrito, whereas this group is called as nitro. Though the number of oxygens and nitrogen are same, but the bonding structure is different. You have to be very careful while writing these names. Okay, so these names and these different type of functional groups you have to remember. So definitely here comes the mugging up part, so that you can identify which particular functional group it is. Then we'll be using different naming rules to name these compounds or name these functional groups in a carbon chain. So now let's understand the seniority order of the functional group. What exactly is the seniority order? So seniority order means you have so many functional groups. So we have spoken about 25 functional groups right now. Definitely all cannot be of the same priority. Let's say I have a carbon chain and there are 2 to 3 different functional groups are present over there. How will I decide how I have to name my compound? Basically, out of, let's say in my carbon chain, let's say this is my carbon chain and I have 3 functional groups are present. One is functional group 1, another is functional group 2, and a third is functional group 3. And all the 3 functional groups are different. Now when we will name it, we will be taking only one functional group as the senior most group, or the one which is the highest seniority or highest priority. That functional group will be taken as the main functional group, whereas rest of the functional groups will be taken as prefixes or the lower priority groups. So let's say when I say functional group 1, 2 and 3, functional group is the senior most group in the order of the seniority, then the suffix, or you can say when we write word root and then we write "-ane", "-ene", "-ion" to show off what kind of bonding the carbon chain possess. After that we use a secondary suffix, and that suffix is basically nothing else but the senior most functional group. So the senior most functional group will contribute in the secondary suffix, whereas these lower priority functional groups will be acting as prefix whenever we are naming a compound. So that's why we have to know the seniority order. We should know, we must know which particular functional group is of higher priority, which particular functional group is of lower priority, and you should be able to do the comparison, and these all will be very important while you will be writing name. The seniority order again is the thing which is very important to mug up, and you will have to do it. So you don't have any choice over here. You can't ignore it because it is very important part going forward also. You will be using it every now and then, so it's not like it's just a topic for this chapter and once this chapter is over it will be no more useful. It will be required throughout, no matter you talk about grade 11 topics of organic or grade 12 topics. Okay, so everywhere these will be used, everywhere. So it is very important to remember this seniority order. So let's see this seniority order, let's understand. And as I mentioned, the senior most group will be taken into the consideration for writing the secondary suffix, whereas remaining functional groups will be taken as prefixes. So for all the functional groups, we have two kind of names. One, if it is being used as suffix, what is the name? And another is if it is being used as prefix, what should be the name? So now we will be understanding the suffix name for a particular functional group as well as prefix name for functional group. Okay, so the first functional group, or you can say highest priority group, is COOH, which is nothing else but the carboxylic acid one we have just now seen, and the secondary suffix name for it is oic acid, or in some places we also use carboxylic acid as a term to represent this particular functional group. So we can have oic acid or carboxylic acid as a secondary suffix, whereas if this particular functional group is being used as prefix, then the prefix is going to be carboxy. Now here comes the important thing. We already know that COOH is the highest priority group. Then how it can be in prefix? It will always be the senior most group, and it will always be named in these suffixes. Then where will be those cases where this can be used as prefix? So that's a very important part, and we will be learning it when we will be talking about carboxylic acid naming. Okay, so I'll tell you the cases where we have to use this prefix also. Otherwise, in 99.9% cases, you will be using COOH as suffix in your compounds, because it is senior most group in terms of all the functional groups. It has the highest priority, and wherever it is present, it will be used as the highest priority group. Rest of all the groups which are present in the carbon chain will automatically act as a lower priority groups, and their names will be present in the prefix. Next is SO3H. It is sulfonic acid, and as a secondary suffix. So that means if it is the senior most group among the groups which are present in the carbon chain, then it will be named as sulfonic acid. Whereas if there is another higher priority group present along with SO3H, then the prefix will be sulfo. For example, let me just give you a quick example over here. Let's say I have SO3H, CH2, CH2, COOH. So let's say this is my compound. Now here we have two functional groups present. One is SO3H, I forgot writing SO3H, and COH. So I have two functional groups over here. Now if I see the order, my COH has a higher priority as compared to SO3H. And now when I'll name the compound, I will be taking this as prefix, whereas this as suffix. How many total carbons I have in the chain? 3. So name will be so word root will be prop. The bonding is single bonded, so it will be propane. Now I cannot write propane completely because I have to write oic acid as a suffix, and two vowels cannot come together, and hence I'll be ignoring E of propane, and I'll write propanoic acid. Now because your carboxylic acid is the highest priority group, even the numbering will start from here, and this is present on the first position, hence I'm not mentioning any position over here. So it will become propanoic acid. Now we know I'm sorry, this is not true. It is present on the third carbon. So now we know that SO3H is also present, and it is a lower priority group which is present on the third carbon. So it will be acting as prefix, and we will write it as 3-sulfo propanoic acid. This represents that the carbon chain is of 3 carbons, where the first carbon is the carboxylic acid, and on the third carbon we have another functional group present, that is sulfonic acid. SO3H group is present. So we'll be talking about this in much more detail, where I'll show you the comparison, and then we will choose which one is suffix, which one is prefix. This is just a small you can say a hint, or you can say an example I want to give. If you have understood, very good. If you have not understood, let's wait for it. Let's move to the naming. When we'll start naming, you'll automatically start getting into it, and you will understand it well. Okay, next priority group is COOCO. So this group is acid anhydride group, as I have already discussed with you, and the suffix for this is oic anhydride, and it doesn't have any prefix. So why it doesn't have any prefix? Because in whichever question we'll be using it, it will be used in such a way, or you can say we don't have enough exposure to the questions where this can be used as prefix. So you will not find it in any of the competitive exam where your anhydride is acting as a prefix. It generally won't be along with the groups which are higher priority than this particular group. So in our syllabus, we have to deal with this group as a suffix only, or you can say whenever it will be along with the other functional groups, the other functional groups would definitely be of lower priority than this, not higher ones. Okay, so so secondary suffix name for this is oic anhydride. Let's talk about few more functional groups and their seniority order and their suffixes and prefixes. Next is C double bond O. I had already discussed about it earlier. This is an ester group, and secondary suffix name for it is O8 or carboxylate. If we have to use it as prefix, we have two prefixes for it. One is alkanoyl oxy. Alkanoyl means alk will represent how many carbons are there, so basically it will represent word root. And then enoyl oxy, or we can use alkoxycarbonyl. This is the one which is most commonly used. Most commonly used. The upper one I have told you, so that just in case if you encounter this, you should not be surprised at which group it is. It is nothing else but the ester group. We will be talking about the naming of these compounds in much more detail, so don't worry about it. Right now, this table has been placed over here to just tell you the seniority order. You must know which is what is the order of the functional groups in terms of their priority. Next is COX. I think I have put a dash over here. This should not be here. This is COX. This group has a secondary suffix named as OL halide or carbonyl halide. This all information you have to mug up there. I understand there is no logic behind it. It is just mugging up the theory, and yes, some part of organic is mugging up and you have to do it, and these are basics and important basics, so you cannot skip mugging this part. So you will have to remember this for a longer time. So the secondary suffix is OL halide or carbonyl halide. Either of them you can use, or when it is acting as prefix, the name is halocarbonyl. Next is CONH2 group. This is called as amide group. Okay, so secondary suffix for this is amide or carboxamide. Any of these can be used depending upon the situation, or if you have to use it as prefix, it will be carbomoyl. Next is C triple bond N. This is called as nitrile or carbonitrile, again depending upon the type of chain we are choosing, and I'll explain you where we have to use nitrile, where we have to use carbonitrile as a secondary suffix. If it is acting as a prefix, then it is cyano. Mind it, I had told you one more group, that is N triple bond C. This was an isocyanide group, and both the groups, a nitrile group or isonitrile group or cyanide or isocyanide group, both have the same seniority order, and that is why I have not mentioned it in the list anywhere. Wherever the C triple bond N is in the priority order, exactly at the same place as your isocyanide, and the name for isocyanide is isonitrile. Okay, as if you are using it as suffix, and if you are using it as prefix, so I'll just write down it is isonitrile if you are using N triple bond C, and if you're talking about the prefix is going to be isocyanide, isocyano or isocyanide. Okay, but we generally don't get much of the questions with N triple bond C. Majorly we get with C triple bond N. Next, another group is aldehyde group, and the suffix for it is al or carbaldehyde. And if you talk about this being acting as a prefix, then the prefix are going to be oxo or formyl. Either of them you can use, it's your choice. Let's talk about next few more functional groups very quickly. Next functional group is ketone. Secondary suffix for this is -one. So when it is acting as suffix, it is -one. When it is acting as prefix, it is oxo or keto. Next is alcohol. If alcohol is acting as a good or senior group, the name is -ol. If it is acting as a prefix, it is hydroxy. Next is SS. This is thiol, thioalcohol basically. And the secondary suffix for this is thiol, or when it is acting as your prefix or a lower priority group, it is mercapto. Next is amine. Now this can be a primary amine, secondary amine, or tertiary amine, either any of them it can be. All of the three will have the same suffix, that is amine or amine, whatever you want to call it, and the prefix is going to be amino. Next comes in the order is a double bond, which is represented by -ine. Then comes your triple bond, which is represented by -ine. Now here I have missed a lot other functional groups, which basically can never be a higher priority groups and will always have lesser priority than double bond and triple bond, and they will always be acting as prefixes. if you remember, I had told you about halogens, chloro, fluoro, bromo, iodo. No matter these are the only functional groups present in the carbon chain, still they will be treated as prefixes. So I have not included those in the list because those are the ones which will always act as prefix. And what are those generally? So you have halogen, nitro, ethers. All these are the groups which always acts as prefix. So you will get a little more exposure about these or about these functional groups and how to use them slowly. Halogens we have seen quite a lot of questions. Nitro and ethers we have not done much. We will be talking about these groups very soon when we'll start naming or IUPAC naming of the individual groups or the compounds containing the individual groups and then the compounds containing multiple functional groups together. Okay. Now let's talk about one by one about each group, how to name it, how to use its prefix, how to use its suffix, what are different cases, what are different ways of naming the compound containing a particular type of functional group. We are going to understand everything in detail. So we'll go by seniority order, or you can say not always we'll go by seniority order, but today at least I'll be starting with COH, which is the senior most group. So we know the functional group is COH. It is represented by oic acid or carboxylic acid. So it has two you can say suffixes, oic acid and carboxylic acid, but this doesn't mean that you can use oic acid or carboxylic acid by your choice wherever you want. No. So there are the cases where we have to specifically use oic acid, and there are cases where we have to specifically use carboxylic acid. So how to use this suffix, we'll be learning that. Then comes your prefix. As I mentioned, it is the senior most group, so ideally it should not have any prefix. That means it should never act as a lower priority group. But where exactly we'll be using this prefix, that also we will understand today. So what is the general formula of carboxylic acid? I'll be a little faster over here. Before moving ahead, let me just tell you, I'll be a little faster because we already know a lot of things about naming. So I'm hoping that you'll be able to grasp it, you'll be able to understand. Just in case if you find any difficulty in understanding about and understanding anything about naming of any functional group or any chain, you can ask me in the doubts class. So this is our general formula RCOOH, which is the general formula of carboxylic acid. And how will we name the carboxylic acid? In general, it is named as alkonic acid. As I mentioned, oic acid is a secondary suffix, so that's how we are using it. So we are writing it as alkane plus oic acid. So here, when I have to combine these two names, E and O are coming together, where E and O are both are vowels. So I have to remove E from alkane, and I will be writing as alkan oic acid. Now, when I'm talking about this alkan represents the total number of carbons in the carbon chain, including the carbon of the COH. So total number of carbons represented by alkane. So basically, if you have only one single carbon that is of COH in the carbon chain, then this will be meth or methane. Okay, so alk is basically the word root which represents the total number of carbon, not only the carbon chain. We are not excluding the carbon of COH, we are including the carbon of the COH while we are calculating the word root, or while we are calculating the number of carbons and writing the word root. Okay, so let's see a few examples of carboxylic acid. The first and the smallest carboxylic acid is HCOOH, where I have one carbon, only one carbon is present, and that one carbon is of COH itself. There is no other carbon chain attached to it. It is directly attached to the hydrogen. So one carbon word root is meth. So when I said that the name is going to be alkanoic acid, it is going to be methanoic acid. Okay, this is its IUPAC name. It has a common name which is formic acid. I hope you would have learned about formic acid in grade 10th in acid, bases and salts chapter. Next is CH3COOH. It contains two carbons, so ethanoic acid. It is also called as acetic acid in the common name. This also you must have heard. This is nothing else but vinegar. Next is CH3CH2COH. The carbon chain is made up of three carbons, and hence the name is propanoic acid. So I have given you the name of three simple carboxylic acids till now. Now we will see different variations in the carbon chain as well as the addition of new functional groups in the carbon chain to understand the naming of the carboxylic acid in the various different aspects, or you can say how the naming can change, how the complexity can increase in the carbon chain of a carboxylic acid. So now if you see here, I have a carbon chain here which is CH3, CH2, CH, CH2, COH, and I have a CH3 over here, that is a branch. So what we are going to do over here is we will try to find out the longest possible chain as per the rule, and this is my longest possible chain. Now I have methyl. Mind it, COH is a very high priority group, and we also call it as the initiating group or chain initiating group. So whenever you are marking your chain or you're numbering your chain, your numbering will always and always and always and always will begin from COOH, no matter wherever the COH is present. So wherever the COH is present, that is the first end of your carbon chain. So there are two ends of the carbon chain. So first is going to be your COH always. So COH can never get another number until unless there are two or more than two COH are present in the carbon chain. So if there is only one COH, it will always get position 1. So this is position 1, 2, 3, 4, 5. So we know now methyl group is present on the third position, and I have COH or carboxylic acid chain made up of 5 carbons. So name is pentanoic acid and 3-methyl. Right? Let's talk about the next compound. Next compound, I can see my COH is present somewhere in the middle, but I told you just now, remember this is the chain initiating group. That means the chain will always begin from COOH. So COH is the Amitabh Bachchan of the organic compounds. So wherever the COH will be present, the chain will initiate from there. Okay, a chain will start from there. So my chain will start from here, and now we will try to find out the longest possible chain. So this is my longest possible chain if I'm including COH and marking it the first end of my carbon chain. So my positioning will be 1, 2, 3, and 4. So CH2, CH3 is acting as a branch. Rest of the carbon chain is the main chain. Main chain is made up of 4 carbons and the butanoic acid, and on the second position we have CH2, CH3 present, which is acting as a branch. So this is 2-ethyl. Next compound. Next we have CH2 double bond CH-COH. Now I have a double bond in the carbon chain and COH. Which one will get priority? I have already shown you the seniority list, and COH is way above the double bond. So obviously my COH will get the first position, whereas double bond will get the rest of the position, whatever relative position it will have in the carbon chain. So we will not try to give the best position to double bond. Here we will try to give the first position to COH. So starting from here, 1, 2, and 3. So COH on the first position, carbon chain is made up of 3 carbons. So it is prop. Now double bond is present on the second position, hence 2N-oic acid. Okay, now here there could not be any other position for double bond because on the first position COOH is present, and automatically if there is a double bond it will shift to the second position. So there is a high chance that you may not find the compound being written like this. Instead it is written like this, propanoic acid. So it is pretty obvious if the chain is made up of 3 carbons and 1 carbon is COH, the double bond is going to be between second and the third carbon. Okay, that's the reason you may find this particular compound is simply written as propanoic acid rather than mentioning the exact position of ene. Next is this compound. You have 4 carbons, again a double bond here. We will start numbering from COH. So my double bond of the chain comes on the second position, and the name will be but hyphen 2 N. N2N represents that the double bond is on second position, and then your oic acid. I'm not mentioning the position of oic acid. Why? Because always the position is going to be 1. Next, in the next compound, let's see what we have is 2 COH groups now. Till now we were dealing with the questions where we had only single COH. Now we have 2 COH, and both the COH cannot get the first position. Only one will get first position. So basically these groups are also called as chain terminating groups. So these are chain initiating and chain terminating groups. So basically when I have to mark the chain or my principal chain or the parent chain, and I have 2 COH present in my carbon chain, my chain will initiate or will start from one COH and will end up at the another COH irrespective of its size. So no matter the size is lesser or the number of carbons are less, but still if I have 2 COH, the coverage of the principal chain should be in such a way that my one end will be one COH and another end will be another COH. Okay, so I will start numbering from here. Here we don't have multiple choices, so I can simply take the straight chain. One COH will get position 1 and another COH will get position next. So this is COH, CH2, CH2, COH. So I have 4 carbons in total. So butane butane. I have not written butane over here. I have written butane. Why? Because now it's not going to be oic acid, it is going to be dioic acid. So I have written butane 1, 4 dioic acid. But mind it, you don't have to necessarily mention 1, 4 because we know that our chain will start from COH and will end at COH. And if the carbon chain is made up of 4 carbons, automatically first position is for COH and the last position is for COH. So we can simply write butane dioic acid. So you may find questions where they have simply written butane dioic acid and you have to think that the first carbon is COH and the last carbon is COH. There cannot be any other possibility. Now, let's talk about the next compound. I have CH3CH OH, CHCl, CH2, COH. Now, as we know that COH is anyways a very high priority group or the best priority group or the highest priority group, we have to initiate our chain with COH, taking the longest possible chain. So this is my longest possible chain. Starting from here, 1, 2, 3, 4, and 5. I have 3 functional groups over here. One is carboxylic acid, another is halogen, and third is alcohol. Now I told you halogens are something which are always in prefix irrespective of whatever, even if they are alone in the carbon chain or they are with the other functional group, they will always be treated as the lowest priority groups and will always stay in the prefix. Now among OH, Cl and COH, anyways we know COH is the highest priority group and then comes your OH and Cl. Okay, so both OH and Cl will be acting as prefix whereas COOH will be acting as suffix. So your total carbon chain is made up of 5 carbons, so it will be pentanoic acid automatically. Now we already know chloro is the prefix for Cl, and what is the prefix for OH? The prefix for OH is hydroxy. Okay, so let's see the position of chlorine. Chlorine's position is 3rd and hydroxy position is 4th. So we'll be writing 3 chloro, 4 hydroxy according to the alphabetical order and pentanoic acid. I hope this is clear for you. I know I'm a little faster over here, but I'm assuming, as I mentioned, I'm assuming that you would have a better clarity about naming by now, and it'll be easier for you to figure out the names and grasping it. I mean, it'll be a relatively faster process now as compared to the previous few classes. So I'm being a little faster over here, just in case if you are stuck somewhere and you are not able to understand, you must ask it in the doubts class. So now we have understood most of the cases where we are using carboxylic acid as oic acid suffix. As I mentioned earlier that we have two kind of suffixes, one is oic acid and another is carboxylic acid. Till now we have used only one suffix, that is oic acid. We have not used carboxylic acid suffix till now. So we are going to learn now some special cases where we have to use COH as carboxylic acid rather than using oic acid. So which all these cases are? So carboxylic acid suffix is going to be used in the case where we have cyclic compounds. So wherever we will see COH being attached on the cyclic compounds, we will be using suffix as carboxylic acid rather than using oic acid. This is the first case. And second case is where COH group is repeated. Now what does it mean? Let's see and directly understand with a question, okay, because this won't make much sense when just sentence is written. So let's directly look at the questions here. So here if you see, I have a cyclic chain and it has a COH attached to it. As I mentioned, it is very clear that for a cyclic compound, we will not be using oic acid. Instead, we will be using carboxylic acid term to represent that there is a carboxylic acid group present over here. Second important thing, we will be just using the carbons of the cycle or you can say cyclic structure. We will count them as the principal carbon chain, and COH completely will be called as carboxylic acid group rather than the previous case where we used to count the number of carbons present in the carbon chain plus the carbon of COH. So here we are not including the carbon of COOH while counting the total number of carbons. We are just going to count the carbons of the cyclic chain. COOH carbon is not getting counted when we are writing the principal carbon chain. Okay, so here this is my main chain which is made up of 6 carbons. So it is cyclohexane, and the COOH completely excluding we have not included the carbon of COH while naming the main chain. So COH completely will be named as carboxylic acid. So I hope you would have understood the difference. In the previous case, the carbon of COH was also getting included in the main principal carbon chain. Here we are not including the carbon of COH while counting the total number of carbons in the principal carbon chain. We are just counting the carbons of the cyclic chain, and COH is being treated separately as suffix, and complete COOH has the name carboxylic acid. Okay. Next, look at another compound. I have a cyclic chain and two COH present over here. So these two COH again will have their names as carboxylic acids. Now these are present on two different positions. So this is 1, 2, 3, and 4. Again, one COH will get first position and another will get the respective position. So one is on the first position, next is on the fourth position. So it is cyclohexane 1, 4 dicarboxylic acid. Let's talk about the third structure. Now, in the third structure, if you see, I have three COH present in the carbon chain, each attached to CH2, CH, CH2, basically COH present on the three carbons attached. So now there are two ways of naming this compound. One is the modern way and one is the old way. I'll explain you both the ways and I'll tell you how to attempt a question if a question has been asked on this particular compound or this kind of compound. Okay, so here what we are going to do is there are two possibilities. One possibility is I can ignore all the three carbons, as I have mentioned in the cyclic chain also, that you ignore the COH, you treat COH as a complete one group. Okay, and the whole principal carbon chain is the cyclic chain. Exactly same thing I'm applying over here. I'm not counting the carbons of COH. I'm excluding the COH and treating individually those COH as the functional groups. And rather than using oic acid as my suffix, I'm using carboxylic acid as my suffix. Why? Because I'm not including the carbon of COH in the counting of the principal carbon chain carbons. So here I'm just taking CH2, CH, CH2 as my principal carbon chain, and all the three COH are out of the carbon chain and will be named as carboxylic acid. Okay, so in that case, my main carbon chain or the principal carbon chain is made up of three carbons. So their name is propane. And on the first carbon, second carbon, and third carbon, there are three COH groups present. And hence I can write 1, 2, 3 tricarboxylic acid. This is what exactly I was talking about, that we can use a carboxylic acid name when there are multiple COH groups are present or when these are getting repeated. This scenario, or you can say this case, is only valid when there are three or more than three COH groups are present. Okay, not lesser than that. So I have taken the main carbon chain or the principal carbon chain like this, excluding COH, and COH are being treated separately and we call them tricarboxylic acid. This is the new way of naming. Whereas what is the old way of naming? Let me just explain you. So in the old way, it is exactly how we always follow, that we will try to find out the longest possible chain. And when we are trying to find out the longest possible chain, my chain will start from COH and will go and will end up at the another COH. So no matter how much I try, one COH will go out of the system or out of the main carbon chain or out of the principal carbon chain. In this case, my total carbons in the principal carbon chain are 5, out of which 2 are carboxylic acid. So the name is going to be pentane dioic acid. Now this COH, no matter how much I try, I cannot include it in the main carbon chain, and hence this will be acting as a branch. This is the case where it is acting as a branch and hence it is acting as a prefix. I told you ideally COH should not act as a prefix because it doesn't have any other functional group which has a higher priority than COH. So ideally it should never be used in prefix, but this is the case where we use it as prefix. So now COH is acting as a branch, hence the name will be used as prefix, and the prefix of carboxylic acid is carboxy. So if I number, it is 1, 2, and 3. On the third position, there is one COH group is present, and we call it 3-carboxy pentane dioic acid. This is old way of naming. By the way, if you get a question like this and there are two options given, one is this name and another is this name, you will ideally mark both of them as the right answer if the question is multiple answer correct. If the question is single answer correct, in that case you will be marking the new way of naming as the right option and you will ignore the old way of naming completely. Okay. So this is about some special names of carboxylic acids where we are going to use carboxylic acid as a term rather than using oic acid. Let's see a few more interesting names and cases of carboxylic. So next, in the last part of carboxylic acid is dicarboxylic acids. This is a generic, basically compounds where you have a chain which starts from COH and ends at the COH. So two COH will be present in the carbon chain, and there are some common names which are important. So rather than randomly giving you the common names, I thought let's just write it down in a list and let's understand the way how these common names have been given. Okay, so if I talk about the general formula of dicarboxylic acid, it is going to be COOH, CH2, COOH. It's not CH2, CH2N. So basically your chain will start from COH, then there will be some carbon chains in between, and then it will end at COH. That's why we have written it as COH, CH2N. Now this N can start from 0 and can go to any number, but we will be dealing only till 6. Okay, so if I have 0 CH2s in between, that means my one COOH is directly connected to the another COOH. That's how the structure would be. In this case, the common name of the compound is going to be oxalic acid. I hope you remember you have learnt about oxalic acid in grade 10th in acid bases salts chapter. Okay, so this is the oxalic acid. If you want to talk about the IUPAC name of it, it is basically nothing else but two carbons in the chain, so ethane, and both the carbons are oic acid, or you can say both are carboxylic acid. So the name of the compound is going to be ethane dioic acid. This is a simple IUPAC name. You must know how to write these names, but these names are important. Basically, common names are important because when they have to confuse you or when they have to complicate the question, any competitive exam people, then they will, rather than giving you the IUPAC name, they will give you the common name, and you must know the representation of those common names. So here I have used a code. What do you mean by a code? Basically a shortcut to remember the common name of these compounds of dicarboxylic acid, and that code is OMS gaps or Ohms gaps. I call it as Ohms gaps, and these are the initials of the common name. So first common name just now we have encountered, and that is oxalic acid. So this represents O. That means first dicarboxylic acid, or the smallest dicarboxylic acid, is oxalic acid. Now if there is one CH2 present in between, then the chain is going to be like this. Total number of carbons are 3 in the carbon chain, out of which 2 are carboxylic acid. The common name is malonic acid, and IUPAC name is going to be propendioic acid, right? Again, see, its initial is M and it is OM over here. So if you just remember Ohm's gaps, it will be easy for you to remember these names later on. Next is when you have two CH2s in between. So COH, CH2, CH2, COH. So total carbon chain is made up of 4 carbons, out of which 2 are carboxylic acids and 2 are CH2s in between. The compound is called as succinic acid. At least these three are very, very commonly used in organic, and you will find them very often in the questions. So this is succinic acid, and if you talk about their IUPAC name, the name is going to be butane dioic acid or butane 1,4 dioic acid. You can write it either way. I had told you there cannot be any other position for 2 carboxylic acid. Your chain has to start from one COH and end at the another COH. So automatically position is going to be 1,4, nothing else. So if you don't write 1,4, still the name will be absolutely right, and the name will be butane dioic acid. So you need not to necessarily mention 1,4 over here. Next is when there are three CH2s in between. So COH, CH2, 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 COH, and the name is glutaric acid. Again, it's G of gaps, and the name is going to be pentane dioic acid. Similarly, if you have four CH2s in between, total carbon chain is made up of 6 carbons, so it is hexane dioic acid. If you want to talk about the common name is Adepic acid. This is again one more very important common name, which you will encounter very often, and this is A of gaps. Next is when there are 5 CH2s in between. So COOH, then 5 CH2s and another COH. So total number of carbons are 7. IUPAC name is heptane dioic acid, whereas the common name is pamelic acid. This is not very commonly used, so you won't find it much anywhere. I mean, but still, it's good to know the information, because if you find it, you should know what exactly it is. Next is COH, CH2, whole 6 COH. So basically 6 CH2s in between. The compound is called as subbaric acid or octane dioic acid. So these common names definitely will have to mug up. There is no other way out. For IUPAC names, we have learned the rules and you will be able to write them on your own. So you won't have to think or mug up these IUPAC names. Just you have to remember the rules what are required to write the IUPAC names. Okay. So this is all about carboxylic acid. In next class, we'll be talking about other few functional groups like sulfonic acid, alcohol, amines, and so and so and so and so. So here I'm ending my today's class where we have understood the naming of carboxylic acid and what all different functional groups we have, what is the seniority order. In next class we'll be covering few more functional groups and their namings.